Good morning, everybody. We have folks joining us. We're just getting started here. Thanks so much for joining us today. We're going to wait a couple minutes just for people to keep joining us before we really get started. In the meantime, I want to say hi to Anna, our special guest here from Climate Science Alliance, and we'll explain a little bit more about what she does there and what they do in general. Right now, we just want you guys to know that you're muted and you can't see each other. You can say hello in the chat, though. We would love to know what school you guys are at, what city you're joining us from. We'd also love to know if you've ever been to the ocean. If you have, what do you like to do while you're there? Do you like to swim in the ocean? Do you go surfing? Do you kayak? Are you lucky enough to have a boat you get to go on? I see some people saying hi. They like to swim. Hola.
Has anyone seen a sand crab before?
Oh.
Has anyone felt one before?
Unexpectedly, I feel like is often how that happens.
Ooh, I'm seeing like some yes, some no. If you're just joining, welcome. We're talking about the ocean, and if you've seen a sand crab before.
A sand crab. Also, to let you guys know that we are recording this and we're streaming it live to Facebook. So if you want to see closed captions, you can do that on Facebook. Also let you know that when we need to focus or if we're having trouble focusing with the chat, we're going to turn it off and then you guys won't be able to chat with us or each other, which is kind of a bummer. So we hope you guys will be able to focus. But in general, we're seeing some fun stuff in the chat here. What is your name? Hello, hi. Who's been to the beach? What do you guys like to do at the beach? I was talking about sand crabs. I know I definitely freaked out the first time I saw one. I thought it was an alien. But they're also pretty cool. Now that I'm a little older and used to them, I like them. All right, so I think we have, oh no, people are still kind of joining us. So we'll give you all a minute to keep sharing. We're also going to remind people that you can't see each other. You're muted, but we'd love for you to say hi. I see somebody saying they swim and they surf. I've never surfed and I grew up in San Diego and I feel real guilty about that, but I love to boogie board. I do boogie board. Are you?
I am not a surfer, but I am always impressed by people who are good at water sports or they enjoy doing.
Me too. Yeah. You have to have like amazing balance and strength to be able to do that. One day I will. So let's see here. And I'm seeing, okay, I think we have like most people have joined us. So we can go again and get started. And we already said that we're broadcasting this and recording it. We'll also be posting it to our website as a recording as well. And then you'll be able to watch it there if you miss anything or want to rewatch or share with people. You can also see closed captions on Facebook right now if you go to our Facebook page. So we're going to get started now. And I'd like to welcome, well, my name is Lauren Marino-Perez. I work at the NAT, the San Diego Natural History Museum. And today I have Anna Lutz-Johnson from Climate Science Alliance joining me. So thanks so much, Anna. She's a friend and colleague, and I've gotten to have her join me 3 times already this year for live programs. This is our 4th and last one. And it's been really interesting learning all about climate change and how it impacts so many different things. Today, we're going to be talking about how climate change impacts our oceans. And there's a lot there. So we have a lot to pack in our short little time, and Anna's going to do an amazing job of walking us through that. So we're kind of just going to skim the surface, pun intended, but and then we'll set you guys up with resources for deeper dives. Climate Science Alliance has really great resources on their website for you guys to get further into it.
Awesome. Good morning, everyone. Thank you, Lauren, for giving us such a great little transition time, getting our brains up and running, thinking about oceans and what role they play in our lives, both in people's lives and within the natural world. So I'm really excited to be here today. Like Lauren said, my name is Anna, and I work for the Climate Science Alliance. And we're a local organization, and I'm really excited to be able to share with you information about our oceans and how oceans and marine life is being impacted by climate change. So that's what we're going to be going through today, is looking at how ocean temperature is being tracked and measured, and how examining some different ways, direct and indirect impacts of climate change and ocean warming. And then we're going to be looking at also how marine ecosystems can adapt well, and some maybe not be able to adapt as well as others. So we're gonna, like Lauren said, this is a great starting off point for you guys to, pun intended, dive in more with your classrooms after the conclusion of this lesson. As we go through our time together today, I'm unable to keep a direct eye on the chat, but we have wonderful other team members on the line who are going to be monitoring the chat. And if any super pertinent or pertinent questions come up, they'll go ahead and let me know. Otherwise, we'll address these questions at the very end of our time together today. So if you're putting something in the chat and you're wondering, why isn't Miss Anna calling out what I said in the chat? Well, if I look too much at the chat, I'll probably get distracted. But don't worry, we have eyes on the chat. And I appreciate any and all questions and wonderings that you may have, or even observations of your own experiences. And last thing that I do want to note, we're going to be using the poll function on Zoom today. So whether you're joining in individually, like from your own device, or if you're joining in as an entire classroom, I'll be giving you guys a little bit of buffer time in between our questions. So you can consider what answer you want to submit, either as an individual or as a class. And maybe if you're submitting as a class, we've had some classrooms that submitted their answers through the chat. For example, 15 students think answer A, 10 students think answer B, so on and so forth. So keeping it flexible so everyone's voices can be heard throughout this process. So I think that covers everything as we jump in now to our water world. One thing to get our brains up and running, thinking about how much water we have on Earth, we're going to go ahead and start with our first poll. What percentage of the Earth's surface is covered by oceans? And that poll is going to pop up onto your screens, I believe. And so what percentage of the Earth's surface is covered by oceans? 24%, 55%, 71%, or 88%. So if you can picture the Earth in your mind, or if you have a map in your classroom, go ahead, take a look and estimate what percentage of the Earth's surface is covered by the ocean. And like I said, I'm going to give this about 10 more seconds. If you want to put your answer in the chat as a class instead, please feel free to do so. But I really love seeing everyone's responses through this poll, so we can share it out at the end of it as well. All right, so I'm going to give it a 5-second countdown. 5, 4, 3, 2, and 1. All right, Miss Lauren, thank you for closing that. And let's see. All right, so it seems like we have kind of a balance between answers C and D, between 71% and 88%. Interestingly enough, the percentage of Earth's surface that's covered by the ocean is 71%. So all of those who submitted an answer for C, you got that question correct. But I really appreciate everyone's involvement. And this is a process of learning, is putting out our wonderings and our estimations so we can find the right answer. So now that we, now that we know a little bit more that a large part of Earth's surface is covered by oceans, and the average depth of these oceans is just under 3 miles. And the ocean contains about 97% of all the water on Earth. So there's not much fresh water, and that's why we're focusing on our oceans today, because that's the majority of water that's on the Earth's surface. So the ocean plays a huge role in whatever happens in the environment. And one of its biggest roles is soaking up energy, which is heat. So, that warmth, that heat that we feel, it soaks up this heat and distributes it more evenly around the Earth. So as ocean temperatures rise along with global temperatures due to climate change, plants and animals are having a really difficult time adapting to these temperatures. And scientists are observing an effect on migration timing, so how animals are moving throughout seasons. They might be migrating earlier than initially anticipated. And then how that changes in migration is impacting species as well. And I always loved this picture. The ocean is the heart of our planet. As we just discussed, the Earth is covered in water. And we like to think of the ocean as the heart of our planet because it's the basis of all life for plants, animals, and humans. It helps, just like our heart in humans' bodies. It circulates our blood and oxygen throughout our body and regulates our temperature. And this is exactly what the ocean does for our planet. It helps control the movement of heat and water throughout the entire Earth. So again, it's this really vital role for organisms, whether it's in the ocean or fully terrestrial, so they're on land. But as we are starting to understand more as a group that climate change is throwing this process and this balance out of whack, and it's causing a big shift. And now we can tell that the heart of our planet it's in trouble. So that's why we're here today. We don't like to just leave everyone at, here's this really challenging information. We don't just want to leave it at that. We want to give a window and a pathway for everyone to examine different actions that you can take to help our planet in the face of a changing climate. And we'll go through that at the end. And yeah, I think what Ms. Lauren, you were going to chime in.
I was going to say, yeah, thank you so much. Because I know whenever we get into this, it can be a little overwhelming, but Climate Science Alliance, you guys do such a great job of giving all sorts of resources and ways that we can make a difference. So we'll definitely share those at the end.
Yeah, thank you. Definitely. Because even as adults, it can be intimidating information. So knowing what some of those next steps that you can take and that fit within your life and your community, that's what we're going to focus on at the very end. So now that we kind of have this big picture of, we have a lot of the surface of Earth covered by oceans, but what actually is ocean warming? So like we said about comparing oceans to our hearts, they regulate our body temperature and aid in circulation. Our oceans do have that same role. They control movement of heat and moisture throughout the Earth and regulates the atmospheric temperature. So not only the temperature within the ocean, but also within the atmosphere. But as more carbon dioxide is being released into the atmosphere due to human activities like driving a car, flying airplanes, warming ocean temperatures have drastic impacts. And it's happening both on land and sea. So this ocean warming, we're seeing an overall uptick of temperature throughout the globe. So as land-dwelling humans, we might be more aware of climate change happening on the land, but oceans are also getting hotter. Any rise in temperature can cause large changes in the Earth's overall climate, as well as the ocean's circulation patterns and chemistry and the ecosystems. And if we want to think of it in this term, vital signs, if you've been to a doctor and they say, we're going to go ahead, check your vital signs, they're called vital because they're all important signs of your health. And the measurement of Earth's ocean temperature is a vital sign of the health of our planet. So when we're looking at the ocean's temperature, it's telling us the overall health of our planet. It's a good sign, an understanding of how our planet is being impacted by climate change and human activities. So even though it might just be 1 degree, if we're thinking in temperature, a rise of 1 degree temperature in Fahrenheit on a sunny day here in San Diego doesn't have a huge effect. There's a little one. But if we think on a global scale across the Earth, a rise of 1 degree in Fahrenheit makes a huge difference. Just think, normally water at 32 degrees Fahrenheit is ice, but water at 33 degrees Fahrenheit, it turns into liquid. So these small changes might not seem that big where we are in San Diego, but they have a global impact, and they can change, like we were talking about, the overall temperature of the waters, circulation patterns, and atmospheric temperatures as well. And that's when I think I would assume a good amount of you are familiar with the idea of rising seas. So flooding in some places can happen and droughts in others. And it means that while some animals, plants and animals, can thrive in these temperature changes and conditions change, it means that other ones don't thrive, and it's impacting humans as well. And I'm going to briefly touch on this because, again, as Ms. Lauren mentioned at the beginning of our time together, there's so much information that we're going to go over today. So I really appreciate you guys being here. I'm not going to spend too much time on this, but would encourage you guys to look into this more after our time together today. But so going back to, how do we even know that oceans are getting warmer? Well, since the late 1700s, oceans, or ships in the ocean, have sampled and recorded the temperature of the water. There are different robotic devices, and you can see, I think my mouse will turn on. Yep, right here in the front of the picture, that's one of these devices that transmits this data, this information. And there are thousands of these floats all over the oceans on our planet. And this gives us, the more information we have, the more data we have, and with more data, we can understand what is happening to our oceans now. And again, as the ocean is this vital sign for the Earth's health, we can understand the health of the Earth now and predict how it might change in the future and what might happen in the future. So if you're unfamiliar, again, these are all really big concepts. So if you're wondering, you have some wonderings, or maybe a word that I've mentioned that you're unfamiliar with, I'd encourage you to keep a mental note or a physical note. Go ahead, write that down, as I've been mentioning climate change a lot, but what I wanted to spend a little bit of time on is what climate change actually is. So climate change refers to the type of weather that a place experiences over a long period of time. And weather is local and temporary. So if we think, for example, today here in San Diego, it's, low 60s, partly cloudy, or at least where I am. But last week it was a little bit different. It was quite a bit sunnier and warmer. Those temporary changes are weather. But we know overall San Diego's climate is usually sunny and in the 70s. So as our climate changes and the world warms, we will see this impacting different places all across the world in different ways. And so as we're thinking about this on a global scale, climate change is caused by increased human activities that release different gases into our atmosphere, and one of them being carbon dioxide. So these are these little gray bubbles here. They're much, much smaller. We can't see them by the naked eye, but these gray bubbles give us a good example when there's too much carbon dioxide in our atmosphere. That causes the heat that's coming into our Earth. It's not able to escape anymore. You can think of it kind of like a heat trapping blanket. So if you put a big fleece fuzzy blanket around the Earth, none of that heat that's coming in can get out. And when the heat can't get out, the overall temperature begins to rise. And we have our second poll today that we're going to tie this into our focus on oceans. Is now we know that there's this excess heat that's trapped around our Earth because of carbon dioxide. But the question I want to pose to you is, what percentage of this excess heat trapped because of increased carbon dioxide goes into the ocean? So how much of this heat do you think is going into the ocean, this excess heat? We have our first option, 23%. Second option, 45%. Third is 70%. And the final one is over 90%. So how much, I'm curious to see, because might be a new concept. I know it's a new concept for me to think about is, okay, there's a normal amount of heat that gets caught in our atmosphere, and we want that because without any heat, we'd be way too cold for life. But there's too much of that trapping going on of heat. And so where does it go? What percentage of it goes into the ocean? So I'm going to give you guys just a few more seconds, and I'll give you a countdown similar to our first poll.
And
So
I'm seeing, oh, sorry, Anna. I was going to say, I'm seeing Miss G's 5th grade class is giving us a count that 2 people think 23% and 3 people think 45%. And I'm thinking some more might be coming in a minute. Oh, 12 people think 70%. So that bumps that number quite a bit.
Awesome. And you said that was Miss G's class, is that correct?
Yes.
Awesome.
And 3
Thank
people
you.
think 90%. Okay.
Great. All right. Well, shout out to Miss G's class for using the chat function. I love the diversity of answers, but also love the poll function as well. So that gives me gives all of us a good understanding of what we think might be happening to this excess heat. How much do we think is actually going into the ocean?
Yeah. And I think their count kind of tips that 70% guess too.
Absolutely. So I'm going to give 5, 4, 3, 2, and 1. Let's go ahead, close that poll. And let's see. Thank you. Oh, wow. Interesting. It looks like the second, third, and fourth options are quite balanced, quite evenly balanced. So this question is designed to stump you a little bit. It's challenging because this might not be something that something that you've considered before. I know it's something that I don't often think about is where is this excess heat going? But I'm going to go ahead and close that poll. Thank you guys for participating in the chat and those polls. It's very, very helpful. So the percentage of excess heat that's trapped because of increased carbon dioxide that's going into our ocean, that excess heat is over 90%. So all of you that guessed 90% and over, you guys got the right answer. So Ms. G's class, I think there were 3 of you. I can hear the cheering now. But again, really appreciate you guys, even if you selected a different answer. That's all about what science is learning together. So, but over 90% of this excess heat is being absorbed by our ocean. Only about 5 or 6% of this excess heat goes into Earth's atmosphere, continents, and into the ice caps. The oceans are absorbing vast amounts of heat and protecting land plants and animals from this heat, for now, at least. The ocean sucks up that carbon dioxide from the air, and it's a natural process, and it acts like a big carbon sink. And as we burn fossil fuels like oil, coal, and natural gas, it starts to absorb more and more and more of that carbon dioxide. So we can be very thankful for our oceans, but maybe if you guys want to put in the chat, if you were yes or no, if you were surprised that, were you surprised by this question, by the answer to this question? I know I was when I was learning more about this.
I definitely was. Yeah, I had no idea that the ocean even served that function.
Exactly.
It does a huge job.
Exactly. Because, I'm more of a land dwelling human. I know other humans that love to be near big bodies of water in the ocean, but I would have never thought to thank the ocean for serving this vital function.
Right. Yeah.
So how does this, now we know how this warming ocean temperatures are being recorded, and why it's happening, but how does the impact of warming ocean temperatures, I'm going to rephrase that, how does warming temperatures impact ocean life? So I'm curious what you guys would consider, what you guys think ocean life will be impacted by through this process. So humans can control how hot and cold we are. So like today in the mornings, it might be really, really cold. So you have a warm jacket on, but in the afternoon, it gets warmer and you're playing at recess. You're probably not going to keep that jacket on. So you get to take it off and cool down. But ocean animals like to live at a really perfect temperature for their settings. They've adapted and grown into this, but they can't control the temperatures that they exist in, not like humans can, at least. So if the ocean gets too warm, then these plants and animals, they have to either adapt or they'll eventually die. So that's why we're going to dive into another portion of our discussion today. Is not only is our sea life being impacted by a change in a rise of temperature, but also by changes in the chemistry of the ocean's water. So I have another poll that we're going to throw up in 1 second. Lauren, I'll tell you when. But this picture, it's pretty in depth, but when we were talking earlier about how carbon dioxide, again, those are those gases that are released by burning fossil fuels. A lot of them are being absorbed into our oceans, and it is impacting sea animals like crabs, and not only crabs, but maybe even other organisms as well. So let's go ahead and launch this poll. As we were talking about how the ocean is a very sensitive system, not only in temperature, it's poll 3. So
I'm sorry.
That's okay. So we're going to be thinking about not only the temperature, but it needs to be the right chemistry. So if the water is too acidic, or if it's too basic, it could impact the way sea life lives. But as more carbon dioxide is being absorbed into the ocean, we're seeing a change in the chemistry of ocean water. So this is a true or false statement. If there's too much carbon dioxide in the ocean, it makes it very acidic. So the ocean, true or false, too much carbon dioxide in the ocean makes it very acidic. What do we think here? This one's a little bit tricky because it might be a new concept to think about the chemistry of water. It's a lot of information that we've all been learning today, but I'm going to give us just a few more seconds to consider the impacts of too much carbon dioxide. If it's making it too acidic. Okay.
And so this is also the same carbon dioxide that the ocean's absorbing out of the atmosphere, right?
Correct.
Okay.
Wow. So there's too much. When there's too much of it, it's becoming either.
Somebody's asking what is acidic. So you kind of went into. I know that's chemistry.
That is a really, really good question.
It's a good
question. Something very acidic. If you've ever had a lemon before, so there's something called pH. And it can be very acidic, so you're low on the pH scale, or very basic, which is going to be higher on the pH scale. And something that's very acidic usually is going to break things down. So if you think of, if you've ever had something sticky on your hands, or glue, and if you put like a citrus oil, or that citrus juice gets on it, it'll break down. So that's what we're thinking of in terms of it becoming acidic. So let's go ahead and close that poll and see what our, great. I'm surprised by this. And this was kind of a tricky question because we didn't cover this concept too much as a group, but too much carbon dioxide in the ocean makes it very acidic. That is a true statement. So thank you all for participating. And I love the questions that were posed in the chat, such as what does it mean to be acidic? These are all great questions that I encourage you guys to keep diving into even after our lesson is concluded for today. So when there's too much carbon dioxide in our oceans, it becomes very acidic. And this process is called ocean acidification. And sometimes this extra acid, like I said, makes it hard for sea animals like crabs to build their shells. And here we go. Oops, my bad. Went forward when I didn't mean to. So as the ocean acts as this regulator, keeping our planet balanced, it can get thrown out of balance when there's too much carbon dioxide being absorbed. So the ocean is no longer able to keep up with this important process. And that's when we're seeing more of this ocean acidification happen. So not only is our sea life being impacted by rising temperatures, but also by this ocean acidification. So some organisms might do okay when the ocean acidification occurs, and others, so like our sea stars here, they might do okay as this acidification process occurs, but others, like our mollusks, aren't going to do very well as climate change and ocean acidification impacts become more prominent. And but we know that it's not just shells that are being impacted by ocean acidification. So we know that snails, mussels, and clams will have difficulty in building their shells, and they can even dissolve. And it actually impacts skeletons of other marine organisms, and tiny plankton, corals, and even sea urchins can be impacted by ocean acidification.
Wow. It's a lot.
Yeah, this is something that I didn't even think about that could happen, because again, I'm more of a terrestrial bound human. I'm not one that spends too much time in the ocean, so I don't see these changes occurring in front of my eyes. But here's an example of ocean acidification in action. So if you, over a 45-day period, you can see on your screens these pictures of the shell. This water is too acidic, and it's both dissolving the shells, and it makes it harder to grow shells in the first place. So here is a picture of a shell that's been placed in seawater with very acidic conditions. And over time, we can see that it's beginning to dissolve away at day 45. And I believe this is our last question, or our last poll of the day that we're going to go over. Is we've been talking a lot about ocean acidification's direct impact on shells and certain type of organisms, but how do we think the entire food web will be impacted by ocean acidification? And if this poll shows up a little funky on your screens, I'm going to read the questions or the answers aloud for you guys, because sometimes the formatting gets a little funky with longer questions. But so in terms of ocean acidification and looking outside of one organism, how do we think the food web is going to be impacted by ocean acidification? Our first answer is there won't be any impacts on the food web. The second is ocean acidification will only impact fish. Or the third is impacts the entire food web, from tiny plants and animals to large animals such as birds. And the last one is impacts only animals with shells, such as sea snails and mussels. So I'll give us a few more seconds on this. And again, please feel free to utilize the chat box if there's some differing answers and ideas with this question. So again, we're thinking about how ocean acidification might impact more than just these shell-dwelling organisms, how the entire food web will be impacted. So give it just a few more seconds. All right, give it a countdown. 5, 4, 3, 2, and 1. Let's go ahead, close that poll. Thank you. Let's see. All right. Okay, so it looks like a majority of answers were tied between our third and fourth options, that it'll impact the entire food web, or the fourth option, which was it'll only impact animals with shells, such as sea snails and mussels. So thank you guys again for participating in these polls. And here you can see not only does ocean acidification, and I'll explain this picture, ocean acidification impact certain organisms directly, but it impacts other species and organisms indirectly. And what I mean by that is when the chemistry of the ocean gets thrown out of balance and becomes more acidic, it's going to impact our sea snails and slugs, some of our shellfish, but larger animals up in the food chain and in the food web rely on these other smaller organisms in order to survive. So no longer will these larger organisms be able to feed on these smaller ones, and it impacts everything, both big and small. And we can see this. We can see this played out in what a kelp forest would look like with sea otters. That they are a key species in this system, but when these animals are removed, then everything gets thrown out of balance. So each organism plays a very, very key role in making sure that everything stayed balanced in these marine ecosystems.
I was gonna say, and kelp forests are the sort of like underwater forests we have here right off on our own coast, right? Like in San Diego.
They're beautiful, absolutely beautiful, very complex. And so with that, I'm going to briefly go over everything that we've learned today, which was a ton. And again, I encourage you guys to jot down any notes maybe, or questions or wonderings or ideas that you might have, just so you can hold on to them, because we covered a lot of information today. But in closing, I wanted to take out these key points for everyone to draw their attention to, which is the ocean. The ocean is the heart of our planet, and it controls the movement of heat and water throughout the earth, and it keeps it from getting too hot or too cold. And the heat trapping blanket is making it hard for the ocean to do its job and keep our earth healthy. So as more of that carbon dioxide is getting trapped in and around our atmosphere, acts like that heat trapping blanket. And the ocean warming will make it harder for marine species to adapt, as we saw more towards the beginning of our time together today. But the ocean also naturally acts as a carbon sink. And so it absorbs a lot of that carbon dioxide that's being released. But as it absorbs more of that carbon dioxide, the ocean becomes more acidic. And as it becomes more acidic, it affects different marine species in different ways. And it can make it hard for animals like crabs to build their shells. And then it can impact the entire food web as well. And as promised, we want to draw a lot of our attention to this portion right here. Is now that we have a better idea and understanding of how our oceans are being impacted by climate change, ocean warming, and ocean acidification, we can discuss some things that we can do to help. So Ms. Lauren, we've gone over this 10 things I can do to help poster so many times together, and it's something that I love to use. So out of these 10 things that you can do to help the earth, which one of these do you think would be your climate commitment?
I always love all of these, and I try and definitely do all of them to a certain extent, right? But and we'd love to see you guys throw in the chat. I see Edwin is saying number 3, recycling. I'm big into recycling. Picking up trash. I like to go around my neighborhood actually and pick up trash. So I'm feeling number 4 strongly today.
That's a good one.
Yeah. How about you?
Yeah, that's what I like about these different climate commitments, is that, you can pick whichever one fits into your everyday life, and one that can help you and your community, because everyone's surroundings and community is different. So go ahead and put your climate commitment, if you want to write it out, or put just the number, you're welcome to, in the chat. My climate commitment, I think, is using less electricity. I can often forget to turn off light switches when exiting a room, or unplugging like different appliances or gaming systems that I might not be using for a long time. That helps use less electricity. So that's probably
Yeah.
mine. I can pay more attention to and give more effort.
And I'm seeing some people say save water, walk or ride your bike. That's something we can definitely do,
Yes.
every day, which is awesome. And start an earth-friendly project with your friends and family. I love that one. That's kind of like
fun.
a bigger commitment, but once it gets going, it's just kind of part of your everyday. It's a new thing.
And it's a great time for it with the cooler weather.
Yes, it is.
Definitely. All right. Well, feel free to keep sharing. I love these climate commitments that are rolling in the chat, what yours is going to be. We're going to, since we're running up on our time, we covered this already, our climate commitments.
Yeah.
I know there's a really exciting opportunity, Lauren, that you wanted to share about.
Yeah, this kind of falls into that number 10 of starting a climate friendly project with friends and family. Is right now you can actually at the end of the month, early January, take part in a community science project, which is where you're helping science basically, and it helps us better understand climate change. You can do community science throughout the year, and right now you can take part in the California King Tides project. So all you do is you have a smartphone, a camera, go outside, take photos of the shore, and you upload them to this King Tides project on January 2nd and 3rd. I have high tides, and we're trying to see, the California government's trying to see like how high are those tides going to be? Are they going to be even higher than last year? Is sea level rising? And over time, taking all these pictures kind of gives us an idea of if our sea level is rising, if it's staying at a healthy rate or not. We can compare them. So if you go to the website there in the chat, it'll tell you where to go to take pictures, how to take them, and where to share them. So we encourage you to do that, because that's a way to help our climate as well. It's a project you can get involved in.
That's awesome. That's
Yeah.
super exciting. Yeah, I think it's doing projects like these are always very fun. And it's a great way to get directly involved in community science and, interact in this scientific process, and especially one that's local. So with that, I think we just have a few minutes. Shout out to Miss Lauren. She picked this wonderful picture that I think captures a lot of our moods today for Friday. Nice and relaxed. But if anyone has any questions, again, that was a ton of information, and we so appreciate you guys joining us today and participating in the polls and the chat. So if you have any questions on anything that we discussed, please feel free to go ahead and pop them in the chat box.
Yeah. I think somebody's enjoying the animals. These are elephant seals resting on the beach. And they're actually on an island off the coast of California, one of the islands that we're so lucky to have here. And I'm trying to see, I know that, I think somebody's asking a question about if the ocean temperature rose to 100 degrees, would anything survive? Which is a great question. And that's really like a complicated one too. Huh?
That's a really great question. I think that hits on, it depends, like if the entire ocean was at 100 degrees, some species organisms might be able to survive. But let's say if it's an animal that's used to really higher temperatures in the ocean, maybe something that's in the 80s, like if you're thinking in the Gulf of Mexico, where they have warmer ocean temperatures, or something close to the equator. But if it's 100 degrees, in the North or South poles, I'm not a marine scientist, but I doubt that any of our big organisms would be able to survive that big of a shift. They wouldn't be able to adapt.
Right. Almost, because that's like being in a jacuzzi, right? Like if you think about hopping in a jacuzzi and how warm that is for us as mammals, it's like too much.
So they can't get out.
Exactly.
Right.
You don't just stay in for 5 minutes and then hop in a cold pool. Like, yeah, you're kind of just cooking in there.
Definitely.
Yeah, that was a good question.
Good question. Yeah.
I know we threw a lot at people, and I know that this is kind of like the end of our partnership, but we're definitely going to be partnering again. And you guys can keep checking in with Climate Science Alliance on their website. They have a really cool Climate Kids website, right? And social media. And we will be having another program. We have them every month. So January 14th at 10 a.m. Fossil Fun will be joined by a paleontologist at the museum named Chris Plouffe. He's really fun and he knows all about fossils in San Diego, and that's what we'll be talking about, San Diego fossils. So hopefully you can join us for that.
It's exciting.
Yeah, and we put the Climate Kids resources link in our chat as well. So definitely check those out. All sorts of cool videos and crafts, just projects you can do to better learn about how to take part in climate change and just how it's also affecting our world. And there's even kind of neat traveling trunks, teacher kits that Climate Science Alliance has put together with lessons that you can check out actually from the museum, from our loan program. So you'll definitely want to check those out as well, as you can take them and use them in your classroom, which is amazing.
Awesome. I had so much fun today. Thank you for having me. And
thank you.
Bittersweet. This is our last lesson.
I know.
Of the series.
Sad of the series, but yeah, there will definitely be more. More, because I've had so much fun having you on here and it's just been great.
It's been awesome. And I appreciate everyone that's joined us and given us such great answers.
Yeah. And so, yeah, we'll say bye and have a great rainy Friday and a great weekend, everybody. Thanks for joining us.
Bye, everyone.